Every onboarding and transaction your platform processes hides a key question. Can we trust this customer right now? In this module, you'll design risk engines that combine rules, machine learning, and human judgment into fast, explainable, regulator-ready decisions. Think of a modern eKYC or AML platform as a four-layer risk engine. At the bottom, raw data flows in from KYC checks, transactions, devices, and external lists. Next, you normalize that into reusable features, velocity metrics, geolocation patterns, behavioral signals. On top of that, a scoring engine blends deterministic rules with machine learning to assign risk scores and flags. Finally, a decision layer turns those scores into actions: approve, hold for review, or escalate for enhanced due diligence. Risk engines are only as good as the context you feed them. Here, risk is a composite signal built from multiple streams. You start with static identity attributes, then layer on KYC and AML outcomes like risk tiers or sanctions hits. Next come device and network signals, followed by behavioral data such as spending patterns and velocities. Finally, you enrich everything with external intelligence from consortia or bureaus. Architecturally, your responsibility is to ingest, normalize, and correlate all of these in near real time. You can think of your KYC and AML engines as hungry for data, but the privacy layer decides what they're actually allowed to eat. First, minimize. Only ship attributes you truly need. Then enforce purpose limitation. Data collected for onboarding isn't a free-for-all analytics feed. Wrap everything in strong access control, masking, and tokenization, so analysts and vendors see only what's necessary. Finally, apply retention rules, so data is deleted or archived on schedule. Your detection logic must be powerful, but always privacy first by design. In AML and KYC, raw events aren't enough. You need engineered, reusable risk features. Start with filtered transactional and device data. From there, compute temporal aggregations like monthly velocity, ratios, and rolling counts. Build behavioral baselines per customer or segment so you can spot deviations, not just absolute thresholds. Then add network linkages, shared devices, IPs, funding sources, and graph clusters. All of these features should feed into a governed feature registry that is versioned, standardized, and fully auditable. When you design AML or risk engines, think in two modes: deterministic and probabilistic. Deterministic rules are simple: if X, then Y. They're fully explainable, easy to implement, and often required by regulators, but they're rigid and generate many false positives. Machine learning is probabilistic. It scores behavior based on patterns in historical data, so it can uncover new typologies and reduce noise. But it's harder to explain, needs labeled data, and is more complex to audit. For risk scoring in KYC and AML, you usually want decisions to be deterministic and explainable. Policy as code gives you that. You pull business rules out of the application and express them as configs or policies, so product and compliance teams can evolve logic without redeploying core services. Those policy files then follow a proper change workflow: proposals, peer review, approvals. Finally, they're promoted through dev, test, and production, ensuring consistent, auditable behavior across all environments. Machine learning shifts AML from binary rules to probabilistic scoring. Instead of asking, "Is this transaction risky, yes or no?" you estimate how risky is it compared with everyone else. Unsupervised models surface anomalies without needing labeled fraud. Supervised models learn from past SARs and cleared alerts. In practice, ML works best as a pre-filter or enrichment layer, not a full rules replacement. Hybrid scoring works by layering three perspectives into a single decision. You start from base KYC risk, everything you already know from identity proofing, sanctions, and profile data. Then you add an ML anomaly score, capturing subtle behavioral and transactional patterns that rules would miss. Finally, you enforce hard stop rules for clear red lines like confirmed sanctions hits. These rules must override the probabilistic scores so that regulatory requirements are never averaged away by the model. When you introduce new AML or risk rules, you need two safe testing paths. Backtesting runs the logic on historical data. You compare its alerts to known outcomes, estimate precision, and understand how many false positives to expect. Shadow mode runs the new rules in real time, but only as silent alerts. They hit dashboards, not queues or customers. Together, these approaches let you tune thresholds continuously, catch noisy rules early, and protect live operations from alert floods. In AML and KYC, a risk score can't just be a mysterious number. You need a glass box, not a black box. The system must show how it moved from a base risk to the final score, which factors fired, how many points each added, and why. Investigators should be able to read the explanation like a short story of the customer's behavior, and regulators must be able to trace every point back to clear, defensible rules or model features. A numeric risk score is only useful if it reliably drives different workflows. A transparent decision layer takes that composite score and turns it into explicit actions with clear thresholds. Low scores go straight to auto-approval, maximizing conversion. Medium scores trigger step-up verification or temporary holds, adding friction only where it pays off. High scores must be explainable and enriched, then routed to human review. Design these ranges, actions, and required context as policy, not hard-coded logic. You can picture AML as an infinite loop between machines and humans. The engine fires an alert based on its rules and models. An analyst brings human context, investigates the case, and decides whether it's truly suspicious or a false positive. Crucially, that decision must be captured as a label and pushed back into the system. Those labeled outcomes drive rule tuning and model retraining. If you skip this feedback loop, false positives stay high, blind spots remain, and your monitoring program slowly degrades. When you design a risk or decision engine for KYC and AML, anchor it on 4 principles. First, modularity. Keep data ingestion, feature engineering, scoring logic, and final decisions as separate components. That lets you upgrade or swap parts without breaking the whole system. Second, strong governance. Treat features and rules as regulated code, with privacy reviews and controlled change management. Third, adaptability. Combine rules and machine learning and tune them continuously from feedback. Finally, explainability by design, with cryptographically verifiable audits for every decision, so you can stand behind each outcome.